Let's talk about our place in the universe. Well, the sun began, according to the nebular hypothesis, as a huge cloud of gas and dust out in the middle of nowhere. And this cloud of gas and dust began to slowly spin. Now, what caused it to start spinning, we have no idea. But it began to spin, and because of the gravity of the dust particles and the gas particles, over millions of years they began to pull together, and most of the volume of this dust cloud of gas and dust turned into the sun. Then as the sun's gravity got stronger and stronger, then of course it began to turned into a thermonuclear furnace because of fusion, and turned into what we know today as the sun, which is a small average-sized star. And this picture shows the sun being surrounded by the terrestrial planets of Mercury, Venus, Earth, and of course we don't see Mars on here. But this is the sun and the basic inner planets. To get a better idea of how tremendously huge the universe is, we're going to go this step by step. So we can see here's the solar system. Well, the solar system is just a tiny part, one part of a group of solar systems, our neighborhood. This could be our city block, our neighborhood. And each one of these are stars. They're fairly close to us. You know, we've got Sirius up here, which is about 8 light years away. Barnard star, which I think is about 10 or 12 light years away. But all of these are our next door neighbors. These are fairly close to us as far as the universe goes, as far as the Milky Way Galaxy goes. So these are our neighbors. So here we are. These are our neighbors. This would be, like I said, our city block. And then our city block is located up here in one of the, kind of towards the outside of the Milky Way Galaxy. Now, as we look at the Milky Way Galaxy, it's what we call a spiral galaxy. And if we could see it from distance, it would look sort of like a fried egg over easy. This would be the center of the yolk. And this area is very thick and very densely packed with stars. And then as we get farther and farther out, the stars are a little bit less dense. And we're out here, kind of on the outer edge of one of the arms. And at night, if we look up into the sky, and at what people say, oh, look, there's the Milky Way, what we're doing is we're looking from the outside towards the inside. And what we call the Milky Way is the way we're looking towards the inside of it. But as you can see, we're lost in this group up here. You can't even see it anymore. Talk about starting to feel rather insignificant. Okay, our solar system, our city block with our neighbors, our location within the Milky Way Galaxy, which as you can see, we really can't see. But now the Milky Way itself is about to disappear. The Milky Way is part of a local group. All of these are other galaxies. And a galaxy, for example, the Milky Way is billions of stars. Not millions, but billions of stars. And so now over here we've got all these other galaxies, and each one of these galaxies is billions and billions and billions and billions and billions of stars. I mean, it's just incredible how many stars are out there. And this is just our local group. This would be kind of like our city, okay? Solar system, city block, our city, our state, and now even the nation. So this is the Milky Way Galaxy, which is a group, our local group of galaxies, and then our local group of galaxies is up here in what we call a supercluster. Each one of these dots is made up of hundreds of galaxies. So that means that this supercluster could be thousands of galaxies. And each galaxy, again, is billions of stars. So this supercluster is literally hundreds and hundreds of billions of stars. Okay, hundreds of billions of stars, because like each one of these dots is now a bunch of different galaxies. So this supercluster is just a tiny, tiny piece of the overall universe itself. The universe itself is beyond comprehension. So if you look up here and you see all these little dots, these are now superclusters themselves. So this just makes you feel just how insignificant we are. So if this was billions and billions and billions of stars, this is billions and billions and billions of galaxies. The universe is about 13.5 billion years old as far as we know, and it was formed by a ginormous explosion called the Big Bang. And look up, read up on that, okay? So we've taken a look at the solar system and galaxies and the universe as a whole. But let's bring this down to something that we might be able to understand. If we look here, these are the planets of our solar system. These are the terrestrial planets. And when we say terrestrial, we mean planets that are stone, rocky, dirt. You could actually stand on them. They're solid. And as you see, this is in order of size. The Earth is the largest terrestrial planet. It's also the densest. It's a little bit bigger than Venus. Venus is pretty close to the size in Earth, but that's where the similarity ends. Venus is a fiery, burning mess. You could never survive on there. Then we have Mars, Mercury, and Pluto. And as we can see, Pluto is very much smaller than even Mercury. And as we all know, Pluto is now called a dwarf planet. Okay, here's where Earth starts getting put in its place. You can see we have Jupiter. Jupiter is by far the largest planet. It's by far the largest planet. And then we have Saturn, we have Uranus, and we have Neptune. These are what we call gas giants. If you tried to stand on the surface of either one of these, it'd be like trying to stand on a cloud. You would just start sinking and sinking and sinking. But the thing that's important about this is look how small Earth is compared even to Neptune. And then Pluto, well, he's disappearing. Now, this is where we really begin to feel tiny. If you look down here at the bottom, you see this little dot, that's the Earth, and even Jupiter is small compared to the Sun. In our solar system, the Sun makes up 99.9% of the mass. So these planets together make up like 0.1% of the whole solar system. The Sun is huge, and to us it's huge. But in the universe itself, well, let's just take a look at some other stars. Now on this scale, we can't even see Jupiter; it's too tiny. And over here we have the Sun, and next door we have Sirius. Any of you who've gone out and looked at the stars at night, Sirius is also called the dog star. It's really big and really bright. As you can see, it's a kind of a white star, and it's much bigger than the Sun. It's about 8 light years away from us. Now Pollux is even bigger. Pollux is part of the constellation of Gemini, the twins. It actually forms the head. It's the star that forms the head of one of the twins. Arcturus, you can see, is even bigger. It's part of a constellation called Bootes, B-O-O-T-E-S, which if you look in the sky at night, it looks kind of like a kite. And one way of finding it is if you can find the Big Dipper, you follow the arch of the handle, and the arch points to Arcturus. Want to feel insignificant in the universe? The Sun, you can't even see it. It's disappeared. There was Sirius, Pollux, Arcturus. Now here's Arcturus compared to Rigel, and Rigel is part of the constellation of Orion the Hunter. Betelgeuse is another star in Orion the Hunter. As you can see, Betelgeuse is just enormous, and I've heard it compared like this, that if you could reach out and take the Sun and put Betelgeuse in its place, that Betelgeuse is so much bigger that Venus would actually be hitting the edge of the star. Venus. That's how much bigger it really is. Antares, Antares is part of a very, very beautiful constellation that you can see in the late summer of Scorpio. Scorpio, kind of right in the middle of the body, the back of the head, there's a reddish-orange star, and that's Antares, and you can actually see it when you find Scorpio. You look to the south and close to the horizon, like I said, in August, and you can find Scorpio, and you will actually see Antares. Incredibly huge star. As big as Antares is, the astronomers tell us there's one much, much bigger called the Pistol Star. Now, where it is, I have no idea. That might be something you want to research on your own. But if you look at the Pistol Star compared to Antares, it's a monster. And I've read somewhere that there's actually a star even bigger than the Pistol Star. So there you have it. Makes you feel kind of small, doesn't it? But also at the same time, amazed at what is out there in our universe.